Okay. I have no clue how the audio is. No clue. So someone's gonna have to tell me. Let me put this in the Discord. If I did this correctly and I'm live. I think I did it. I'm in science and technology today is the category. Because I can't be in gaming anymore. At least for this, I guess. I guess chess is a game. Some sort of game. But it's not I don't think we can be under gaming anymore. Hold on, let me take my sweater off because it's hot in here. Okay. Alright. Chess is a game of all time. It is. It is. But I think maybe I'd be getting the wrong crowd in here if I said that we were gaming, you know? So chess engine from scratch. I made a chess engine before, so I know all about it. I did it just based on what is available on the chess programming wiki, which you may or may not be familiar with, but I will pull that up right now and talk a little bit about it. I guess because this is kind of where all of the information is about how to make a chess engine, you know, the bitboard stuff, movement generation to movement scoring, and how to implement opening books and things like this. There are some issues with it. Namely, I think the biggest issue with it is that a lot of the stuff in it is completely outdated. A lot of this was written a long time ago, and so, yeah. But let me pull it up and talk about it. I'm going in incognito now. Sorry for the flashbang, but I'm going in incognito now, just so that, I don't know, to stay safe, in terms of whatever. Anyway, there's a lot of stuff here. What we're going to be doing today is the beginning of movement generation and board representation and architecture. So basically, there's a few different ways that chess engines have historically done board representation. What we're going to be doing is bitboards, which is generally the fastest and best way about doing things. But also worth mentioning historically is the mailbox approach, right? Now it's a bit complicated. I don't really even understand it. But we can go take a look and talk about it. It's can I get the 10 by 12 board is what I'm talking about. 8 by 8 is literally just the 8 by 8 64 squares, but this is a different approach of doing it. Not what we're going to be doing, but I always found this super interesting. So basically there is this square, right, and a rectangle, and then this square around it. And as far as I understand, this is kind of mathematically somehow, I don't really understand how it works, to be honest. So I'm not like the best person to talk about it, but I did know some people that did chess engines with this approach. I don't really understand it. And so that's why I never really did it. It's also just not as fast. But I think that it's like it's somehow the exterior being these in the array um makes sense somehow for uh for like, let's say a knight is on here and then it goes to here, and then you automatically know, since it's a -1, that it doesn't go there, right? I guess that that's what this is all about, as far as I'm aware. But then again, like, why is it not a square? Like, what about 48 goes to here, right? I never really understood it. I think it's a mathematical thing with indices, right? As you subtract 1 to get here or something like that. Coding chess 2 today. Um, Not chess 2. Did I put the title wrong? I hope not. But I am coding a chess engine. I did make an engine before, but it was very inefficient. Or, well, not very inefficient, but much worse than I can make it now. I think I can make it a lot better now. Anyway, so I just thought to mention the whole mailbox things. But what we're going to be doing is bitboards. Bitboards are unsigned 64-bit integers that each bit inside of that integer is a space on the board, right? Conveniently, right, we have a 64-bit integer, and there are 64 spaces on a chessboard. So it's kind of amazingly convenient how that works out, right? How are we going to start with this, right? Well, the way I did this, right, is that I think what we should do today is the easiest pieces, right? The king is a historically very easy piece since it's just the square around it, right? The hardest pieces are pawns, bishops, and rooks. Bishops and rooks we're going to leave till a bit later. The reason why is because of magic numbers, and I'm not going to be making my own magic number generator for this. You can do your own research on how that is generated. It's pretty complicated as far as I understand, with the limited documentation that there is about it. But I will be copying a set of good magic numbers that will be used to generate the bishop and rook moves. If I can explain that properly, there is basically an array of a bazillion numbers that are used to calculate the mask that you and with the current space that the rook is, to basically find its available moves. The reason why it's so complicated is because there are so many different combinations, right? And of course, a rook and a bishop could be blocked on any number of squares. So there's basically these calculations that we have to do to create masks that are pre-computed, right? So that we don't have to do that every time we want to figure out a rook's available moves. Anyway, so the rook and the bishop and the queen, of course, are historically difficult pieces to get efficient, right? Of course, you could write some for loop that simply, checks, but we want to do it the most efficient way. Anyway, so as far as easy pieces, the king is historically super easy. The knight is really easy. And pawns are pretty difficult, but the basics of pawn movement is easy. It's just promotions that can get tricky. Anyway, I think we want to start with like the basic kind of structure. I think we're gonna make a couple of files, right? The first one I wanted to make is also I changed my coding environment just because I was kind of getting tired of the old one for no specific reason. Anyway, I have to update my theme. If people ask me for my theme, I have to update that, I guess. But yeah, I did some work on the theme, I guess. Anyway, we want a types.h, I think. And we want a I guess we could just have a main.c. Oh, I meant to what's the I'm stupid. Oh, do I still have this open? Oh, I do. That's what I meant to do, though. What font is that? Is it Iosefka? Yeah, it is. Wow, how did you, wow, good eye. That's incredible, because I don't even have anything written on this, and you automatically recognize that. That's honestly incredible. That really caught me off guard. Tell me if the music is too low. For some reason, the online player for this is so loud that I had to turn it all the way down. But yeah, I did try a bunch of different fonts, and I like this one the best. There was another font that I liked a lot, but it didn't have an italic, so I can't really deal without an italic. So I think that this font is really cool. I'm of course like a fan of the retro fonts and stuff, but I thought, since I'm starting a new project, I might as well kind of switch it up a bit. I know I'm kind of like a boomer with all of the setup things and all of this, but now I've got this fancy blurred background and whatever. Anyway, it'll be nice that people that watch the stream will stop complaining about the font. Every time I stream, there's at least one person that comes in here and says some to the tune of, can I ask why that you use that font? Or sometimes it's even more demeaning, like change the font please, my eyes, or something like this. It's very common. But we won't get that anymore, because now my coding setup looks like everyone else who's on Arch Linux, Vim, whatever. I'm not going to insult anybody, but anyway, I also want to make a new scratch buffer and call this the UCI. The UCI is a protocol that we will be using eventually to communicate with, how do I explain it, with other chess engines to play against them. The typical way is through this program called Arena, right? Which you may or may not know of, but it's this client where you can put chess engines against each other, and that's what we're going to be doing eventually. But we're going to be using this protocol called UCI to do that. Basically, we get strings and then we send strings out, right? but that's later down the line. I might even want to create a graphical interface. That's what I did for my last chess engine, is it actually had a board and all that. What's the inspiration for Sebastian Log? No. The first time I made my chess engine was, to be honest, I was, just pretty, this is pretty loud, I think. I was pretty lonely and I wanted somebody to play chess with, and playing it online I didn't really enjoy. And playing against other people's bots, I don't know, it just kind of felt too much like a bot. And so growing my chess engine from scratch and seeing it become better to play against until it eventually started beating me, right? It was it was kind of not to be too strange, but it was kind of like a child, right? It's it was seeing it kind of develop. But yeah, there's no I didn't see any sort of YouTube video and want to do it. I just I've always thought that chess is very interesting. I've always liked it. I've never been very good at it. Forget what I was rated when I was playing online. But I had some very drunken nights when Central Park is closing, playing against the chess people there. What I would do is not Central Park. No, I'm being stupid. It is Central Park. I would go. No, it's not Central Park, is it? No, it isn't. It's the park. It's Washington Square. That's what I'm talking about. I worked in kind of the East Village, and so I would walk there after work and grab a couple of beers, and then I would bring them to the homeless chess people there that just sit there and play chess all the time. And they're really good at chess. And we would just kind of drink a beer and play chess. And so I've got kind of good memories of chess, kind of historically over the course of my life. Anyway, big aside about it. But I think also just chess engines are another type of engine, like a game engine. And I kind of just wanted to start over with something new. So that's why I'm doing a chess engine. So I'm going to try to keep this project a lot cleaner than my game engine ended up. So that's going to be the goal. And so that kind of means making another file for... I had this last time, was move generation.c. Do I want to commit to this name? I always have trouble naming things because I end up hating when I name something and then I have to change all the includes later. Move generation.c. I suppose so. And what we want is also move generation.h. Okay. Sounds good to me. I'm going to close this for now. And I guess we can start doing this. What do we want to do? I think we should start with this. How do we do this again? I always forget. I literally forget how to do this every time, which is kind of embarrassing, but I have like awful memory. So I'm just literally going to go and copy some things from my engine. Setup stuff. I think that this kind of gives away the fact that I'm a self-taught programmer. Right, yeah. I need that at the bottom, yeah. What are we mad about? Oh, this is a define. That's why. Oh yeah, that's just this. Okay. We got there, we got there. we got there. Just use Pragma? I have never done that because I've never done C++. Or I did, but I don't remember it anymore. So I was thinking about this last night, what we want to do, or what I want to do. We're going to have the obvious enum for black and white. I wanted to call that... I kind of wanted to call it side. And we're going to have black and white in here. Ooh, gross. Why is this not 4 spaces? Brother? What are we talking about? Hold on. That's gross. What? That's 4 spaces. This is not 4 spaces. Okay, I'm trying not to get sidetracked, but that's really disgusting. That's really disgusting. Okay, but we're not gonna worry about it right now. It's so weird. Hold on. Why are my headers 2 spaces, but my C files are 4? Huh? Like this isn't. You can set it in languages.toml. Yeah, I have it though, which is why this works. But hold on. If I quit, now it works. I think I had this problem before, and it's specifically when I create a new file. No, it doesn't work still. Why? Do I really want to play around with this right now? I kind of do, to be honest. Where is this? Yeah, I have tab with 4. I think that this is one of these things where it just hates C. But yeah. Yeah, I think that this is just one of these things where it just hates C. I'm not going to bother with it right now. Whatever. Anyway. We want these structs. And the first one I'm going to make is... How did I do this last time? Maybe I want a player struct with all of its own data. I think the way I did it before was that I had a game struct with a bunch of things inside of it. I had inside of this basically all of the pieces, right? I think it was like literally inside of an array, right? Where you have all the bit boards. I'm just trying to think like what's the fastest way of doing it. We also want an enum for pieces, I guess. It should be piece, of course. And the order... So what I did before was that I had white and black, for whatever reason, inside of it. So this would be like black pawn, whatever. And there was a reason for that. I think that the reason was because I didn't want to have arrays of arrays, right? Is that I didn't want to have an array that was like took inside and then pieces. Because my kind of idea was that it would be faster to just have one kind of collapsed array for everything. And so that's why I ended up with doing that. I don't know if that's true. So I may just want to just do this. Kind of forget the order, right? But hopefully this is sufficient. I think that this is in order of... I think it might be knight bishop. I think that this is the order. Can't remember if knight is before bishop or not. I think knight is in some situations worth less than a bishop, right? So I think that's the order. So yeah, there's two ways of doing this. There's you obviously could do an array of side that has an array of piece for the bit boards, right? Or you could just do one array. That's kind of how I did it. It was basically 0 through 12, right? Black pawn. Crazy idea. Instead of, could you fit black and white kind of piece info into a byte? Too complicated to work with, but it's great on memory. You definitely could. There was some things inside of my engine that were bytes, or were bits, right? For example, castling rights were 4 bits. Crazy idea coded in assembly. Yeah. That's unfortunately out of my skill set, I think. I think yeah. So this player struct isn't going to be in use right now. A game would have 2 players. It would have you could do this, or see, this is where I always get stuck, right? Is that you could have this, or you could of course have a player, you could have this, right? And so I always get stuck with this, and then whatever I go with, I end up regretting it. As with everything. But yeah. Anyway, so this is the thing, right? Hold on. We want I want a piece data, which is going to have the bitboard why is this not allowed? Oh, I have to include something for this, right? What is the include for that? Cint types, is that what it is? It's apparently what it is, I think, because the error went away, so I'm just gonna assume that that's it. I didn't really prepare for this at all. But yeah, I probably am gonna add stuff to this, but the idea is that we have piece data that is this, plus this, right? Right, and so this is the color, and then this is the pieces. I think that's it. And so this board is going to have basically all the pawns, all the knights, all the bishops, etc. But what I ended up having for this was an extra bitboard that had an occupancy map of every piece, for black, white, and then both. And so we want to also have that. And I'm wondering, that shouldn't go under pieces, under piece data. I think that should go... I mean, you could simply just... we could just not overcomplicate it, right? And just have these two... Now, I'm not sure what is better, right? Because there's 2 ways of going about this, right? You could have this uint64t, and every time you move a piece, update this both pieces variable. Or you could just simply AND these together with a bitwise operator every time you need that data. And of course, that's going to come down to how much you're accessing it, right? If within a cycle you aren't going to use that data, then it would be simply faster to just AND it when you're going to use it. However, I think you do want to update this because you are, every time you're generating moves, for example, when you're generating a king move, you need those occupancy maps. When you're generating a queen move, you need those occupancy maps as both, because you need your own pieces to know where your available moves are. So I think that's how I'm going to do it. So there's that. I kind of forgot how I stored moves. I think I did literally just a string of moves. You could simply just have like a huge array of characters. The question is, so, you know, when you're recursively doing things, I want to make sure that we have that move data available. I believe that the maximum characters is 4, right? With promotions, it's a plus at the end. I think that it's 4. Fen notation, yeah. My thing is, do you do like a do you do like a this with like is this what you're doing here? I think my voice cracked. I don't know what the max moves is, but is this like I think that this is kind of what you're doing. If I'm correct. Linked list seems more appropriate. Yeah. I guess for when it comes to the recursive thing, that kind of makes sense. But the game struct is literally just going to be a these are the moves that we have definitely made. You know, we're not going to be undoing any of this, I guess. But yeah, we could do a link list. Linked lists always confuse me, but it kind of does make sense. It just has a pointer to the next one. I guess. Let me look up the FEN notation thing. It's 4 characters, right? Oh, this isn't actually the moves, though. This is the entire string of the board position, right? Yeah, well then we can just have a the FEN. I don't know what the maximum is. We can count it out, right? So there's a it's basically all the ranks. I should have opened this up in the I'll do it. How about that? I'll do it. Here. So it's basically every single rank, right? So if you had a piece on every single rank, it would be 8, 8, 8, 8, 8. So we can do the math on that, right? So it's that would be 64 straight up, plus the slashes. So 1, 2, that would be 6 slashes, right? So we're at 70. 73 plus the plus this is 4, so 7, 77, 78, and then I think that this can be 3, right? If it's E3 plus, that's a promotion. And I can't remember what a castle looks like. The fent notation is crazy. Yeah, this is what I hate about the En Passant Square, about the chess programming wiki, is that nothing is very well done well. So we're at 77 here, then plus, let's just give it extra room. Let's stop complicating things. So this is going to be 1, 2, 3, 4, 5. And then plus, let's just say plus 5 at the end. So what we're going to end up with is 77 plus 5, so 82, 82 plus 5, so 87. Okay. I'm just going to do that then. 87. Now, if we overflow that at some point, then I'm going to be kicking myself, but whatever. Yeah. But we still do need this move list to keep track of what we did. Actually, maybe you just want this. Maybe that's what you want. To keep track of, and then every time we just increment a move counter. So then let's do that. Okay. Cool. That's cool with me. So we have fens for every board state. I'm trying to think what else we need to get us to perfed. Now, perfed is basically the test that you run your chess engine against when it comes to move generation, to see how fast you can generate all the possible moves from a given position. And if you get a number that isn't correct, then you obviously have something wrong, right? If LA had Washington Square, you'd be able to communicate with local grandmasters in fent notation. Yeah. Fent notation. Okay. So, wait, isn't move counter is inside of the fen, by the way? It's inside of the fen. That's what this is. Full move counter. Starts at 1 and is incremented after each black's move. Okay, well, we're just gonna have this anyway, but don't worry about it because we need to index it somehow. What else do we need? Oh yeah, so this is what I was gonna do. So we need we're gonna have a uint64t pointer. Actually, so what is this T about? I think I'm supposed to be using this is fine, I think. What is the difference? Okay. Okay. So they're the same thing. They're the same thing. And it isn't this. It's what is this? I literally just had it up. Right, it's stdint. Yeah, I always forget the all the things that I need. Okay. So this is going to be a pointer to last time what I did was that I had king moves as an array of 64, right? This is a lot of memory, turns out. And because you also want this, you're gonna have this for, I believe you have it for pawns. And another piece as well, knight. So I was thinking on a knit, we just actually malloc this. I mean, but I mean, having it as stack arrays, I mean, it's faster, right? So I mean, I think that this is fine. It does turn out to be a lot of space, though. I did end up having a Stack Overflow actually with my last engine. That was a legitimate Stack Overflow. It wasn't a bug. I just had a lot of arrays around with pre-computed data, right? Okay, so what I kind of want to do is I want to make the code that generates Stack Overflow. Yes, I said the thing. I did say the thing. Let me go. Let me see. Let me see how I do this for. I do want to put inside of this OpenGL at some point, but I'm not going to get into that right now because that's some setup. I do want to get this, of course. I was wondering, this, I have this, oh, this is SDL. That's why I was confused. Oh, okay. Understood. Okay. I'm gonna do the include thing. and we need to set this up. And inside of the move generation thing, we are going to, I'm going to do the setup math for generating the bit boards for those pre-computed pieces that I was talking about. But I need the header file first before we do it. Okay. So we're going to have a couple of functions in here that are going to do the setup, right? And so I think the first one is going to be generate and this is going to take in a pointer to the game. And we're going to have 3 of these. We're going to have one for the pawns and one for the knights. And of course, we're going to have this that does all of these, which is cool. I want to include the types.h here, and all that good stuff. Actually, yeah. And then this is going to have those functions. We're gonna have all of them in here, and we're gonna do the same thing that I just did. So pawn, knight. And init piece boards. Okay. We want to put king last, is what I decided, because that's just the correct order. And this init piece boards is going to just execute all of these, right? It's just going to do this. Reason I'm doing it like this is just to be tidy, right? And if we decide something else should go in here, then it will. But that's that. So inside of generate pawn boards, we need to do some math. So, okay, before we do this, we want to make a new file, which is going to be our math. So there's actually going to be 2 new files, but I can't do that. Do I want to call it math? Let's see. How long do I think that this will take? Not sure. Definitely not just a couple of hours. There's no, that, if you want my keyboard, you can do ! keyboard, I think. The keyboard I built myself, like, 4 years ago, maybe. A few of the switches have now failed on me. But I had some backups. Also, some of the switches, like the end and page and home key, the end and home key are just some old linear switches that I had to replace it with because they stopped working. It's supposed to be quite a project then, I guess. I mean, a chess engine isn't as complicated, obviously, as a game engine, but it's recursive move generation and scoring, you know? It's if you're doing it without, vibe coding it, then it's something that takes a while, yeah. So I guess is it math? It's not really math. It's actually what we want is bitboard operations. So popping bits, finding the least most significant bit. Do I make a game engine also? Yes. Mainly what's on this channel is my 3D game engine content. That's usually what I stream and upload videos about. And that engine is something that I've spent many months on. Many months on. So we can just call it math. I wish that you could just create a new file with a name, but you have to do this. Okay, so we're already starting to get a bunch of files, obviously. Well, that's fine. You can obviously see why I suck at remembering this. It's because what I do is I just end up copying it for everything inside of a project over and over again. Oh, what am I doing? I'm doing this wrong. Whoops. Okay. So we are gonna need some functions to do this. Trying to think what we need for this specifically. Let's start really simple with set and remove. We want to include types.h, and we are going to is book to RAM soldered? I actually don't know. I've never thought about I've never thought about putting more RAM in it. I think honestly if I opened this thing up it would just immediately break. I mean, this thing is made so poorly. It's incredible. You'd be surprised. Sometimes when I start up my computer it just instantly says that the GPU has fallen off the bus and I have to power cycle it. That happens like about 50% of the times I press the power button. So yeah, I love Microsoft. It's a great company. On an aside, did you hear that Bill Gates is in the Epstein files? That's crazy. That was crazy to hear about. I don't know if he's in it, but I saw him on some sort of list. Which I thought was just, I'm not surprised at all. But yeah, anyway. I did say I would keep the mic closer to the keyboard today because I always hate how quiet it is. Anyway. We want set and remove, and I'm wondering if we go... if this is faster, or if you probably want to just return it. Yeah. Instead of... yeah, this is probably faster. I mean, of course, some people out there are probably going to be like, actually, it's faster to just use a pointer, but yeah. The question is whether dust mite is in the files. I'm definitely not in the files. What's up, Frostix? How are you? So this is going to be a bitwise operator. So this is going to take in an index and the original thing. We can just call it a board since it is a board. And what this is going to do is we are going to we have to make a mask with it. So we take in the index, and then we just return board and mask. Do I sound like Charlie from Smiling Friends? I've never watched that. I did watch it. I think at this one of my friends at their house. I was really sick, and we were just kind of like lying around playing board games, and she did put on Smiling Friends, but I think that is that made by like the guy who does like Oni plays or something. Sounds like something someone who is in the files would say. Yeah, maybe. Definitely not. So I think that works. I'm pretty sure that is how that works. And then we want to do the opposite, which is remove bit at an index. And then this is going to be what is the syntax for this in C? The NAND. Thought you were making your FPS engine? I still am. Bitwise operators in C. I know in Rust they have it the not is a it's this? Wait, what? Wait, hold on. No, you need to. You can't just do this. You have to. It's a two-step process. Hold on. Wait, and this isn't this, by the way. This is an or. But this is an and. Wait, hold on. Am I being dumb right now? The result bit is 1. Oh, is it Zor that is what I'm looking for? The corresponding bits are different. Let me think about that. That would give us... That would work, right? I think so. Because they would have the same... Yeah, that would work. And then you want an operation to flip the bit. Like we can call it toggle. Let me think about how to do this. Oh, new Helix setup, yeah. I need to update the theme. I guess I did some changing around with how things look, I guess. So when we toggle, isn't toggling the same thing as remove? Hold on. I think it is. Yeah, I think it is. Because the mask is always going to have 1, and then if you have a 1, then that becomes a 0. And then if you had a 0, then the XOR is going to set it to 1. So this is a toggle. So toggle is the same thing as remove. Okay, what am I trying to do here? I'm doing some bit boards. So basically, when we want to move a piece in the chess engine to a specific place, obviously, then we take in the index of that location, and then we're toggling that bit, right? And so I'm just trying to make sure that the bitwise operators are correct for this stuff. So basically we have an integer that is 64 bits. That's every piece on a chessboard, every space. Remove could be toggle and check if the bit is 1. Yeah, I just think that would be that would be like an extra operation that isn't really necessary, you know. I guess we could have this and then like put a comment here that this is less efficient. Also checks if the bit is 1. And what we could have is a I like bool. We're gonna have a boolean that says if the bit is 1 or 0. So we're gonna have it as a check bit, right? And that is going to check a bit. It's going to be the uint 64t and the index. And it will just check the bit at a certain index. And we are just going to simply return it's just literally going to be the set bit, right? It's going to be the same thing. And this is going to be we're gonna AND it with the mask. Yeah, that. So basically what this is doing is it creates a mask with a bit at a certain index, and then it ANDs it with the board, and then if it's greater than 0, then we know that there is a bit at that location. And so to do this remove bit operation, what we're going to do is we're going to call check bit with the board index so if check bit board index, then else we will just return the board. In line with board, and that is true. That is true. I do have to get into the habit of doing this. Wait, hold on. This is the other way around though. This is the other way around though. Yeah, this saves memory-wise too. Yeah, you don't need this. You just literally can return return this. And then yeah. I think that we just inline all of these in the header file is like the fastest way to do this, right? I should really get into the habit of doing like things the like fastest way, because honestly, a chess engine, you wouldn't think it, but it's kind of less forgiving than a game engine. At least from what I remember performance-wise. Because you're doing these operations so many times, it's kind of ridiculous. Yeah. Oh, yeah. I have to add inline, of course. Check out branchless programming. Interesting. Isn't inline obsolete? Not as far as I am aware. I mean, maybe the compiler does it automatically, but maybe. From what I've read, though, is that it's just good practice, though. I don't really know. See, I don't really understand when to do static inline, but I think that it's fine to do static inline when you don't have when you aren't dealing with pointers. Anyway, when it comes to like my math library, most of my stuff is static inline, so that's just what I'm gonna do. Okay. So this is the optimized way of doing this, I suppose. OMC. So we are going to take in the math, and I'm going to take this into here. Okay, now inside of here, we are going to use this these functions to set the bits that we need to for all of our moves from a given position, right? Now, this doesn't have to be the most efficient way, since this obviously is going to be all the stuff that we just do at init, right? So we're going to have just a straight up init function. Obviously, we should be returning an int for that. And this is just going to set up our game state, right? And for now, I'll just have game here. And so we will set up our game state. You know what? It's probably just like better to have this as like a, you can just like make this a global variable. Like I'm not even that stressed about this being global at all. So I want to init piece boards with our game. This is so clean and neat, and this is exactly what we want it to be. Okay. I have to return an int from that. We're just going to say return 1 for now. I'm just going to do this. That's cool. Okay. Yeah, sorry, I'm not really explaining what I'm doing, but just doing some like initialization boilerplate. If our init fails, then we want to just return -1, right? And eventually we'll just have like a cleanup function that cleans up if we have allocated any memory or whatever. So init just calls init piece boards, which just sets up our all of the moves from every given position. And that's what we're going to calculate right now. So I think the easiest is going to be the king, because it's literally just a square around the king. I have to kind of think about how we're going to do this. I think what I did before was I literally just had an array of numbers that were just added, right? So we have, what we're gonna have is an int array called moves, and it's going to be 8 or 9, and it's going to be let me think. So -9, -8, -7, -1, +1, +7, +8, and obviously not plus, but now let me just think if this is correct. Basically, this is creating a square, right? When you add 7, it goes down a row and to the left, right? Also, this is 8, by the way. Yeah, I think that this is how we do it. And all we want to do is have a current index from where we're starting, and we just want to for loop over it. Sorry, I just lost where I was on the keyboard. And what we want to do is we just want to and then that's just going to be indexing the moves, and we just want to add proposed index equals the moves indexed by S yeah. So this is getting us, we're going through all of the spaces on a board. We are looping through all of these, the ring around the king, and we are adding it to our current index. Okay. Now we want to just have an if statement, right? That checks if we're negative or over 63. Hey, what's up, noob? Hello again. Okay, so if our proposed index is less than 0, it's easier to just check greater than. Ooh, that is gross that this font does that. Oh, I don't like that. Oh, I don't like that at all. I'm not going to worry about that right now, but that is just disgusting. Sorry. How do people code with that? What? That is gross. That is just gross. Okay. Okay. Which, you know what? I'm also going to make this a define. Okay. So if we are less than our board max or greater than or equal to 0, then the move is valid, right? And so what we want to do is we have our game, and inside of our game we have our king moves, which we are going to index by I. And we will set it equal to the set bit you want to do this down here after we loop through all the moves, but we want to make you could just do this here. You just do this here. And just pass in the current board every time. And the index is going to be proposed index. And so we are going to set the move board for every given piece equal to the set bit of itself at a current index. Ever tried Zig? No, I haven't tried Zig. I've dabbled in Rust, but not Zig. I'm kind of, I guess, just old school, like boomer with things, sort of, you know. Yeah. So I don't know if I would really appreciate the benefits it has to offer, I guess. So this automatically just seems correct. Something I want to do is, and math isn't the best place to put this, but for now we can just do this. I want to, you know what? Since we are being super clean, we're gonna make a new, and I will say that this is going to be called utils, okay? Okay, utils. And we're gonna take the same boilerplate into there. Utils. Okay. And we're going to have, we can just do, it's not really worth inlining, I think. It's just kind of pointless, right? We're going to have an include utils.h. We also want to include our types. And inside of this, what I'm going to have is a print function for printing our board so that we know that our math is working correct. So I'm going to have a print board that is just going to take in a uint64t board, and we will just print that to the terminal. And that is just going to loop through. We're going to do, I think we do a nested loop here. Or actually, we can do it more efficient than that. So let's just do I less than board max. And we will do this. So probably have to modulus something here. Let me think about it. We're just going to have an if statement that breaks the line if I modulus 8 is 0, right? Is that correct? Hold on. I modulus 8 is 0 and I doesn't equal 0. Oh, that's awful as well. Ugh. How do I turn that off for a font? That is just... This is criminal. That is criminal. Maybe I'm just a boomer, but anyway, that's just... whatever. Is it... I literally am like the worst programmer of all time. Oh, it's stdio. That's what it is. I think it's cout that is what I'm getting it confused with. Anyway, we're going to print. Oh, what we want to take in is the piece information for this. So I want to take in actually a piece, and that will determine what character we have. And since that's a thing, what I want to do is within types, I want to have a global array, I think. That has the piece names, or the piece characters, I think is the best way to do it. I have to remember how to do that though. It's I did this inside of here. I had some stuff that was externed, right? And this is going to have, it's going to be 12, because you want black and white inside of there. Actually, now you're kind of wanting to do this. Yeah, I think so. Because if we're gonna do this like this, then we might as well do that like that. I wonder, like, what's faster? I don't think... Is this, like, indirection? If you have... If you don't do a flattened array? That's what I always assumed. So you would just have this as 12 instead. But then the enum becomes so nasty. What's up, Isabel? It is chess time. I think you do want this, by the way. And you just have a different enum for when you're doing both. Because that just makes everything so much more efficient when we're looping through. So we don't have to nested loop everything. So I'm just going to have a different enum that does all of the... That has both of the color and the piece. What do I want to call that? Maybe I actually want to call this piece type. And then this one will be piece. Because I don't want piece. Piece has to actually have... That's why I did it this way in my last chess engine, is that piece has to have color in it. I kind of wonder what the I think we're just gonna do this. What I ended up doing though was I had it like this, as like all of the white pieces and then all of the black pieces, and I don't know if I want to... I'm probably going to shoot myself in the foot here by doing it this way, but I think that this is better. I guess it doesn't matter since we're not actually going to be looking at indices at all. Anyway. Oh right, knight is n. Knight is n, believe it or not. they didn't really think when they were creating the game of chess that knight and king start with the same letter. I feel like it would have saved me a lot of headaches if they just called them different things, because now knight is N. Anyway, so what was I doing? Right, we were printing out our board. I want to make a function that gets that character. Right, that's what I was doing. I was making the array for piece names. Piece names? So I'm just going to make that as a thing here. And we are just going to do that like this and just copy exactly. I can probably do like something fancy here and just like literally copy this down. And all I'm going to do is I'm just going to index it with that. And yeah, I can do the thing here. Okay, cool. So we are just going to print can I just literally do piece names indexed by piece? Format string is not a string literal. Potentially insecure. You're potentially insecure. Fine. We will do that. Can I literally just do this? Like, why are you being such a jerk? I think that this is fine. Hopefully that doesn't crash my computer. Okay. Earlier me would have just like literally made a switch case, but I'm not going to do that this time. Okay. So that prints a board of a given piece. I also want to make a function that prints the entire game board with every kind of piece. And so to do that, I'm going to get rid of this. And I'm just going to take in a game pointer game. Okay. And this can stay. But I need to write some code that checks all of the piece boards for a given location and then prints out the piece that exists there. And so we want to iterate over all of the piece boards. So there's 12 piece boards for each type of piece in each color. And what I want to do is we made this check bit before, and so that's going to take in the game is it pieces? Is that what we called it? And dot board, right? And then the index is going to be RI. And so we're just going to say if check bit, if there is a bit at that location, then we will printf the, we're going to do this index by P. Yeah. There, that actually turns out pretty nicely. So we're just going to loop through all of the pieces and then print the piece name for whatever we get. Of course, we also need a Boolean that no piece equals false, equals true. And no piece, in this case, no piece equals false because there is a piece there. But if we get through the loop and there was no piece, if no piece, then I will print f a blank space. I forget what blank spaces were when I did this last time. I think that it was just a dash. Hopefully I'm remembering that correctly. I'm not really sure. I think it's that. Now, if we want to get fancy, we can specify, of course, the ranks, right? And so this isn't just going to be a new line. Right, so we can start off by printfing the, well, if we want to be like super correct about this, then we can also do the same thing with rank names. This is 8. Right. What do they call columns? I don't know. That's how you spell column, right? Files. It is files. You're so right. You're so right. File names. Okay, so that's what I'm gonna do. Is I'm just gonna have 2 global. We're also gonna make them enums as well, but that's just what this is going to be. We should probably put this in a different file. But give me a second. I'll do that in a sec. File names and rank names. Okay. So this is just going to be literally 1 through 8. And this is just, I'm just doing this so that it's efficient when we're printing everything out, because what we're going to end up doing is there's going to be a time when we're going to be printing out, you know, thousands of boards a second, but we aren't quite there yet. So this is going to be this. There is an H. There is an H. That is 8. Okay. There we go. I can probably put the music a little bit louder. Okay. Why are we mad? Oh, we're mad because I'm dumb. That's why we're mad. Okay. So that's what we're gonna print out after our new lines. I'm just going to start off by printing the first one because this happens. This creates a new line after every we get to the end of the row. And so what we want to do is we want to do one to start off, right? And so we will do rank names indexed by 0. Printf. What am I writing? Yeah, I need another coffee, to be perfectly honest. Yeah. So that will do the first one. And then when we get to a new line and we're not 0, we want to print the next rank name, which will always be, we are indexing rank names by, okay, let me think. I have to do the math on this again. Is it I divided by 8? Hold on, let me, yeah. That is, right? Yes. Yes, sirree. Yes, it definitely is. Okay. Yes, sirree. Okay. So, at the end, then we want to print all of the files. So, I'm just going to do this, a loop over all of the files, and we will just print all of that info at the bottom. Okay. Now, hopefully this works. I think that this is fine. I'm not sure if I want to have all of that information in print board. I think that that keeping it in print game board, we can make a third function that prints out the all of that information. But I remember sometimes just wanting the raw bitboard printed out without the, without that. So hopefully I did all this correctly. I'm not really sure if I did, but to my eyes it looks fine. I will compile this in a little bit, I guess. The reason I did this is because I want to print out, we have to put this in the header. I want to print out these boards. I want to print out these boards that we are that we're generating, because I don't want to do all this math and then have to go back and change it, right? Okay. We are going to print board for game king moves indexed by I. And it's going to be the piece of well, we don't know if it's actually white or black. So for now, we'll just default it to white, because the white and the black pieces are gonna have the same exact initialization board. So at the end, I just want to print game board, I guess, with the game. Wait. No, I can't. No, because we don't actually have the pieces there. Okay. Well, I guess it's almost time to compile it and check out if this is working. Init calls init piece boards, which calls generate king boards, which loops through, and then will print out all of the boards. Yeah, we can just test, I guess. Let me... I don't think I need any of these flags other than... Yeah. I don't need any of these library flags, right? I don't think so. Okay, I think what I'm going to do is I'm going to make the exact same shell script for this, though. Because I am a jerk. And I'm lazy. And a jerk, and I don't like makefiles. Hold on. Okay, so, just going to link everything that we just made. Okay. What is set E? I think that set E is actually, it like makes a new terminal window or something. Anyway, let me see if this is going to work for us. Okay. Multiple definition. I may have like a include loop, hold on, with the move generation thing. Yeah, I think I have an include loop here. Hold on. First defined here. Multiple definition of init piece words in C. What did I do? Oh. Wait, no. I'm not including it here. No. I probably have like a recursive include loop somewhere. Do I need this? Yeah, I do, to print the board. It's every single one. It's the annoying thing. I'm almost interested to see if I literally just comment everything out if it compiles fine. Of course I have to do this, but well, yeah, of course. I wonder where it is. Yeah, that compiles fine. Let me just check this function that does nothing. Put it in the header file. Wait, I'm doing this backwards. Yeah, I was just doing it literally backwards. My header was including my C file, but my C file is supposed to include my header, not the other way around. That was just me being a bit dumb. So I'm gonna include types there. Okay. Okay, now I have to put in the shell script that we're gonna run it. Can I just literally do this works, right? Yes. Okay. Okay. So we are getting our boards. There is this happening though, which is interesting. And we need to start off with a new line as well. Or we could do the thing where we put a new line at the end. Which I think is what I'm going to go with. That's like my typical convention. Right, and there we go. I kind of want a line to separate them, and so I will do one at the start. Then you can literally just do this. Okay, now I have to figure out why we're getting both capital K and the not capital K, the lowercase k. Piece names Can I literally just not do a string and do a... Is it this? Yeah. I was being super dumb. Because I never use that. I never use characters, so... that should give us the correct result. And let's make sure that that gives... Yes. So here we go. Interesting, though, is that every piece... every piece has a king. So... Oh, that's because we don't actually check and print board if our board is correct. So if our board has a piece. So if... So we have to write check bit for our board at our current index, then this, and else we want to printf a blank space. Okay, and there we go. There we go. And now something we're gonna notice here is that we are wrapping around. We are wrapping around. And so that's the next thing that we have to do. But obviously, as you can see, we are setting up our king. Something else I'm noticing is that there's two. So there's two. So probably have some bug there. Let's try and track down. So it's here and here. But it's only supposed to be here, obviously, at the 0 index. But it's ending up here. Interesting. And this is 1, 2, 3, 4. So exactly halfway. Okay, so let's go to our initialization and try and piece together what's going on here. We print out for every one out of the 64. So therefore we're 100% sure that it's happening in here. I wonder if it's the set bit thing. So what I'm going to do is, instead of that, what I'm going to do is this, is we're going to print out after every set bit. After every set bit, we will print out the board just to... Okay, so let's take a board like this, for example. It is happening every one. At every one, it is setting 2 at exactly 4 above. So that probably means that our set bit isn't working. Ah. Yeah, I think that this is why. I think this has to be this, and the reason why is because it doesn't automatically make a uint64t. So let me just make sure that that's the issue. No, it's still happening. Oh, you know what it is? It's 100% not that, and what it actually is that we don't actually zero initialize any of that. Any of the king moves, I think. So let me do that then. Let me try that. No. Let's try something else and print out the proposed index, I guess. Even though I doubt that that's what it is. So this is printing it out before and after. So after there are two. Oh. That might be why. Yeah, that's why. Or not. No, that's not why. I want to make absolutely sure that my print board is correct. Maybe my check bit isn't actually correct. Make sure that this isn't being dumb. Because it's exactly 4 extra. So I just want to make sure that this isn't that this isn't no, yeah, this is still happening. Okay, here's what we're gonna do. We are just going to literally we are going to test that it's not the set bit that's happening. So I want to print the set bit of 0 and a proposed index of 1. And so we will print that board out. I want to just print out, we're going to set. Okay, so it is on the set bit side. And if I set bit 0, then yeah. Well, I don't really know if it's on the set bit side or the check bit side because we have no way to check. Unless, you know what I could actually do is set 63, 0, 63, and then we can check if, printf, okay. This is mad at me because types.h should have, this. Okay. So I want to print out the value of test with a bit at, with 1 bit. I mean, am I absolutely sure that that's, because it's an unsigned integer. It should not be, okay, there we go. Yeah, so it's definitely on the check bit side, actually, on our printout. Because if we set the bit 0, the first index, to 1, then we get 1 back. The value of this is 1. So our set bit is fine. It's when we're printing out that's incorrect. That's strange. So the index is 0, and 32 is also... Something that I could check is printing a board. Without setting a bit, I just want to print 1. Yeah. Yeah, my print is wrong. Yeah, this is the same thing. I probably made a stupid typo somewhere. I just want to check if the index is correct. So this will, yeah, index 0 and 32. Is it this? No, right? That doesn't make sense for it to be that. Yeah, I may need another coffee to figure this out. But I'm so confused. I'm also confused why that doesn't give us something different. I want to check if this is working too. Yeah, that is working. Interesting. Okay, so what I'm reading... Oh, what I'm reading is that this has to... Okay. Does this... No. I think I need the unsigned literal suffix on all of this. From what I'm reading, it says that it might be treated as a smaller integer if we don't do that. Okay, this now let's get rid of this. No, this is still the same issue. And it's going to be the same issue no matter if I switch this to left or right. Yeah, this just doesn't work if you do it that way. Yeah, it's still the same issue, even with the suffix, so it wasn't that. Hi, I'm also working on developing a chess engine. Working on neural nets for position evaluation. That's sick. I did have a chess engine that I finished, but evaluation was something that I always struggled with. Yeah, I never worked with like neural nets. It was all literal position evaluation calculation. But yeah, I never really understood all the fancy, way people do it otherwise. The default operation is 32-bit. Oh, sorry, I'm reading this on the side. I'm reading 64-bit bitwise operations and why the default is 32-bit, and that's why I'm having trouble. Okay, so So, yeah, this is pretty complicated. There are some people saying that I can cast it. Okay, so let me try that. Let me try... I thought that this would be enough, but if I cast this, is this fine? Basically it's yes, okay, so that was what it was. Okay, so the default bitwise operations in C are apparently 32-bit, and so you have to explicitly cast to 64-bit whenever you're doing it before you shift, right? And so that's exactly what was happening. So now when we generate our king boards, it will give us the correct results. We just want to print the board at the end, like so. And as you can see, we're doing it correctly, right? Okay, that took a while to figure out, sorry. Anyway, we're gonna have to fix this now, this wraparound issue, right? And so I have to basically, this is what I struggled with last time was determining if a piece is going to go off the edge of a board. I struggled with getting this correct. Not correct, but efficient, right? Of course, you could just like do some math with where it is currently and if the position is off the board. But there's probably a more efficient way to do this. I'm thinking. Here's a good thing. So a king can only cross to the other side of the board on a certain file. And so what I could do is I could literally just make bit boards for certain files, right? and then just ore it, I guess. Or and it, I mean. I may have to make another coffee. I'm getting to the point where my concentration has run out. But I did fix whatever bug that is, and I will be back in like 5 minutes. I'm going to think about this and make some coffee. So I'll be back in a second. Okay, my coffee is half done. So I've started thinking about how I'm gonna do this. And I've noticed in my thinking about this is that the only time we need to actually check this is when we generate these piece boards. We never have to do it after because the pieces that we do with the magic numbers and all that stuff with, that stuff is all pre-computed anyway in terms of masking. So there's actually no reason for us to really think about some really efficient way of doing this with bit masks and stuff. But I mean we could just do it anyway. There was a website, I can try and look it up. There was a website that generates these bit masks. Bitboard generator. There was a bitboard generator, bitboard viewer, yes. This guy made this website here that here. That just literally generates us string literals for it. I think layout 3 is what we are going for. This is like my my way of doing it. So what I want, so basically my thinking is if we are here, then we cannot go here, right? The reason why it's 2 is because a knight, right, can do this. So if we're here, then we can't go here. And if we are here, then we can't go here. And if we are here, then we can't wrap around, right? Though that isn't happening because we just check if we're greater or less than 0. So the mask is going to be this and that. So we have this literal here that is generated, and we will just literally extern that in our types like we did with the other stuff. I'm just gonna have this at the top, and we are going to extern these as a global variable. What am I gonna call this? It's going to be uint64t. Man, what's a good name for this? Legal. Left file mask. Actually, you know what? Let's just call it one and two file mask, and then we will have 7 and 8 file mask. And these will be defined in our utils. We will make those here. And we will set those to what we generated with this. There we go. And we want to set this. I'm just making sure that these are, so it's this. We also need to make sure that I use the correct notation, the ULL at the end. And there you go. So this is what is externed, so that when we are generating our king moves, we can say if our okay, so my coffee is now officially finished, but what I want to make is an inline, a static inline bool that just checks against a mask without an index, right? So this is going to the reason why this needs to be a function and we can't just do and, or actually we can. I think we can. I think we can if both of them are already uint64t's. I'm pretty sure that it will just do the 64-bit operation and I don't need a cast. So, if game king moves, no, okay. So let's do this. So let's do uint64t proposed move is going to equal the set bit, right, of 0 at the proposed index, and we will and that with our 1 and 2 file mask. And our 7 and 8 file mask. So if we are in those files, we need to wait. Actually, this is not the proposed move. This is the current king position. So you want this to be current position equals the set bit of 0 and I, and then that's what you want, current position. So if our current position is within that, we need to make sure that we don't cross over into the other file. And so what I'm going to do is we will set up a couple other, we eventually will just like have them for each file and each rank, but I just want to set up these for right now. And so I will make 2 more externs. Actually, you know what we want to do is we just want to have all of the file masks and all of the rank masks. So I can just make an array here. And we will have rank masks. And we will define these in utils, just like here. And I will set these up after I get my coffee, which I will get right now. Okay, I'm back. So, what I was doing was we are going to set up these file masks. Okay. Okie dokie, okie dokie. You know what I also just realized that we didn't do is we didn't put in types. We didn't make the enums for the ranks and files, which is what we will do right now. The fastest way of doing this is going into main, and first of all, we want to put these, I changed my mind, not in main. We want to put these in utils, which is where we will just be dumping all of this stuff for now. Okay. And so these file masks are going to be indexed by the enum. And the fastest way to do that is to literally just copy all of this stuff into there. So that's what we're gonna do. So type def enum, and we will have an enum for the ranks. Okay, well, oops. And we will paste all of this in here, and we will select all of these, and we will get rid of them. There we go. And you're mad at me, why? Redefinition of B. Oh, the bishop. The bishop. Okay, well, you know what? I guess we will be doing this. I guess that's what we're gonna do. Sorry. But that's just the way it goes sometimes. And we will copy that same convention for files. Same convention. Actually, I changed my name. We are going to write it out like this because I think that it's better. Actually, yeah, you know, it's what it is. I think it's cool. Cool with me. Okay, one more. I was off. Okay. So those are the files. and that's the file. The file that has the enum for the files. Okay, so now inside of here, we are going to take what is generated here and just copy and paste these literals in an array, which is like really thrilling to watch, I'm sure. Okay, so these are going to be all of the files masks that we're doing. So I'm just going to literally go into here. Wait, actually there's a pattern here that we can observe and probably, you know, wait, hold on. These are doubling every time. So if I'm going to just like literally, I can just do this, right? Hopefully, and then just S4, 8, and then is it 16? Let's test it. That's 8, and then this is. No, I see. I see it shifts over. It does shift over. Wait. Huh? Wait. That's the exact same thing as the first one. I think I messed up. It does have a 0 at the end. I think I messed up. I don't really know how the literals work, but maybe it is just literally just adds a 0 at the end. Interesting. Okay, well, believe it or not, I never did this with my other engine. So I don't really know what these are supposed to look like, but apparently that's it right there. And just for not wasting everybody's time, I'm going to just leave it at that and not do the rank masks right now. Okay, so in our move generation, if our current position is on the 1 or 2 file mask or on the 7 and 8 file mask, then we need to check if our proposed position is on the opposite file. So this is going to be 2 different if statements, right? So else if current position and 7 and 8 file mask. Okay, so we need to make that uint64. We need to do that beforehand so that we can check it. And that is going to be the proposed move. So if proposed move and file masks file 8. So if our proposed move is on the opposite file, then we know that it's incorrect, right? So I suppose that we can just continue, right? And we want to do the same thing, but this is going to be file 1. Then we will continue. And then otherwise, we want to just... Oh, actually, so this is going to... We are going to set bit with a 0 mask, and then we'll just and them afterwards. So, or them afterwards. So we will... This is going to be just the raw move, and then we will set it to game king moves I, and or with the proposed move if it's valid. And I just want to print out that this is doing this correctly, and yes it is. So we no longer are wrapping around the board, and it's all good. So now we have all the valid moves for every position given a blank board, which is what the goal was for this. So this function is complete. Okay, so that's cool. Now let me just do some tidying up. And I will write a comment here that basically explains what this code does inside of here. So this checks against opposite files to make sure we don't loop the board. Okay, we are going to do something very, very similar for the knight and pawn boards. Obviously, the oh yeah, so the pawn boards are interesting, right? I think what I ended up with the pawn boards was you have separate boards for captures. Then you're just regular move boards, right? Yeah. But the knight board is exactly like the king boards. So that's what we're gonna do now. So we're gonna have this move array too. Oh, also the pawn boards are, you have separate boards for white and black, right? Now let's go and take a look actually at our game struct and make sure that we have, yeah, so we have black pawn moves and we have white pawn moves because they go in opposite directions. And we also are going to have white pawn captures versus black pawn captures. Reason why you want these separate, at least like in my opinion, is because you need to, it's faster when you're determining if there are any valid captures, right? At least in my mind, right? Than just like having a mask with everything and then just having to, you know, select which bit is a capture bit and which bit isn't. Okay. So, this is the initialization for this. So let's do the math for the valid moves. So just like a king, I think that there is also only 8 valid moves. It's just the math is a bit different, right? Because it isn't a square. So I have to do some mental math on it. So the first one would be up 1, left 2, right? And up 1, as we know, is -8, okay? And -9, and so that would be -10, okay? And then we want to go up 2, which is -16, right? And then left 1, which brings us to -15. Wait, hold on. Let me. No. No, that's -17. That's -17. Okay, and then we want to go in the opposite direction, which is going to be +2, that. So this is -15. And then we want to go up 1, right 2, which is -8 + 2, which gives us -6. Then we want to go down 1 over 2, which gives us +8 + 2, which gives us 10. Then we want to go down 2 + 1, which is 16 + 1, which gives us 17. Then we want to go down to left 1, which is -2 that, so that's 15. And then we want to go down 1, left 2, which gives us 8, -2, which gives us 6. Okay, so these are actually, I just realized these are just negative and positive, the same ones. So those are all of the valid knight moves from a given position. So let's just do the exact same thing. We can just like copy and paste this. It's very, very similar what's happening here. Very, very, very similar. So I don't, yeah. We are, of course, going to change all of this proposed stuff, though. That is the stuff that needs to change because it isn't the same. So this is going to be knight moves. And right. So we only want to be touching knight moves instead of king moves. King moves. So, okay. I think we want to do the exact same thing, set the current position, and then loop over all of the moves, add the moves. However, of course, we do have to check against a different mask here. We have to check against not only the file 8 mask, but also the file 7 mask, because you could loop around on file 1 and then go to file 7. But you can't when it's a king, because, you know, you're only going just one space. So that's what we're going to do here. File masks, file 7. Okay. And that's that. File 2 would be this one. Okay. So hopefully that's correct. And now just to check our work here, we're going to enable printing for that. Okay, so let's check this out. So as you can see, we have this ring of knight moves, and all of this does look correct to me. Fantastic. Yep. All looks correct. Cool. I thought it was always cool to like scroll your terminal and see it move. Anyway. So, with that, we have our knight boards and our king boards. And that's really the easiest part of all of this, really, is setting up those variables. Okay. Oh, what is this lag? What? What is making me lag so hard? Okay. Should probably mark the knight as N instead of K to remove confusion with the king. Oh yeah, so that was just what that was it was literally my print board takes in what piece it is. So I just copy and pasted the K. Internally we know that these are the knight boards, and not the king boards. That was just a copy and paste thing. Okay, so the pawn boards are of course going to be different for black and white. So that's what I'm going to have to do next. So yeah, I'm getting encoding overloaded. Just like, yeah, I wish I had a better computer. Okay, so it's completely different for black and white. So what I'm going to do is just do them separately. So black and white. So from my convention, it was always black is at the top and white is always at the bottom. Yeah, that was the way I set it up always. So we are going to start at index 8, okay? Because that's the first row. And we will increase to board max, okay, which is 64. And we will do the same thing for here, except it's going to be the opposite. And we will start one row up. So that's going to be 64 minus 8, which gives us 56. So we're going to start at index 56, and I is greater than 0, I minus minus. Okay. Or you could just like go, actually, it's actually not 0 and it's not board max because those aren't valid positions. This goes to 56 and this goes to 8. Greater than or equal to 8. Okay, so this is the opposite sides of the board marching to the other side, basically, and stopping one row up because why is that? Because those are the only valid positions, and if a pawn crosses that border, then it's automatically going to get promoted, right, and not be a pawn anymore. So those aren't valid pawn positions. Anyway, so it basically means that the first 8 of the array are just going to be blank, right? And so I can 0 initialize that for you, like so. So let's move that up here, and I will say game black pawn moves indexed by I equals 0. Whoops, 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 whoops. Okay, we're gonna write that again because I misclicked. Okay, and we're going to do the captures as well. Okay, so we will do the same thing for white, just because I know you're anxious about it. Max minus 1, I is less than 56, I plus I minus minus. Okay, then we will do game white pawn captures I equals 0, and we will do the same thing for the moves. Okay. Fantastic. So now we're going to do the actual logic for generating this, which is literally just going to be the move for the first row is obviously going to just march it twice, right? And so I'll just do, listen, actually, you know what, this is gonna bother me. So we will actually start at 16 and we will just do the first row hard-coded. I equals 8, I less than 16, I plus plus. We will say we want to set 2 bits, right? Because on the first rank, you can always move your pawn 2 places, right? Not at the first rank, on the second rank, because you start at the second rank. So that's what we're going to do, right? So game black pawn moves I equals, we are going to do this really neatly. We can do set bit with 0 and an index of I plus 8, which is us moving down, and we're going to OR that with a set bit of 0 with I plus 16, just to be very, very clear, right? Okay, so that's the game black pawn moves. And then for the captures for this, obviously this is just diagonal, right? In fact, if whatever, let's not worry about it too much. So that's going to equal the set bit of 0 with I plus 7, ORed with the set bit of 0 with I plus 9, right? Because that's diagonal. Okay, so that's the first one, and we are going to do something very similar for the rest of them, right? It's just not going to have this extra one, because you're just going to be moving 1 space. Okay, and that's exactly what it is. Now for white, it's going to be the exact same thing, just going in the opposite direction. So I'm just going to copy and paste it. Okay, so let me actually just take a look at that. So this is starting at 56, and then one more is going to be quick maths 48. And this is going to turn into greater than or equal to, can't figure it out. Let me think. Yeah, it's still greater than. Yeah, it's still greater than, I think. Okay, so this is obviously going to all turn to white. And we are now subtracting. So all of these pluses are going to change to minuses. Okay, and then let's go to this and add an extra minus. And then let's go to this and start at 48. And then while I is less than, and y I is greater than or equal to 8. Well, doesn't this mean it's greater than or equal to 48? Hold on, let me think. 56. I feel like we aren't starting at 56. Hold on. Hold on. Let me think. 64 doesn't exist. It starts at 63. So 63 minus 8. Then. So we don't start at 56, we start at 55. And then 55 is greater than 48. 55 minus 8. This is 47. Yeah, I'm just gonna log it. I'm not going to sit here and be confused with it because I'm just gonna log it. This definitely has to be 8 though. So then this ends up this, and then this just starts at 46, and then greater than or equal to 8 is correct. But to match the convention, it would be this. Okay. Okay. So what I want to do is I want to print all of this out. And we're not going to print it all out at once because that would be very, very overwhelming. But I do just want to log it just to make sure that it's all correct. So I'm just going to print board with game black pawn moves indexed by I with Pete, and I will do I want to actually, yeah, let's just print both of the boards. It's fine. Captures. Okay. And all I want to see is a printf here for index. Okay. Just so that we know where we are in number. Okay. Okay, so we see that this is kind of working. Oh, this is actually just perfect. This is fine. Okay, so we do have an issue with wrapping around the board here, which is true. We didn't actually check for that. But as you can see, this is us going forward, and then this is capturing to the side. Okay, and it's the same here. Move forward, captures to the side, and that's exactly correct. That's exactly what we want to see. Now we just have to deal with wrapping around the board, which is just checking against our mask, just like we did with the knight and king moves. So let's do that. Okay, so moves will never wrap around the board because they only go forward, but captures will. Let me check that we do reach the final rank. We do. That's capture. We move across the final rank. Okay, and then we do. Okay, so let's check once again. We need to check the captures. Okay, so let's set okay, so let's see here. So let's just do this really simply. So let's do uint64t current position equals set bit 0 I. Okay, that's our current position. If our current position and we want to AND it with the file, right? So actually the most efficient way to do this would be to literally just hard code it. Would literally be the fastest way to do it. The best way to do it. And I you know me, I hate hard coding things, but it is kind of the fastest way to, the best way to do it, right? So if I is 8 or I is 17, then we will actually it's more efficient to do it this way. This is kind of cursed. I know it's cursed. Then we will set black pawn captures to only be set bit 0 I plus. If it's at 8, then it will be which is going to be wrapping around. It's going to be +9. 7 is going to wrap. Sorry, a lot of mental like visualizations I have to do with this. And then on the other side, this will not wrap. Okay, so that's that. Now we need to replicate the exact same thing for the rest of the board here. Okay. Okay, so if I modulus 8 is 0, then we will do that, and else if I modulus 8 is 7, we will do this, else this. Okay, so if we are modulus 8 is 0, then we will go in one direction, and that's going to be the 9 direction. Okay, so let us take a look at the captures then. We're only going to print the captures because we know that the moves are correct. Okay, so let's take a look if I was correct. So from our inspection here, it looks like we are absolutely doing the correct thing and my math was correct. Something I want to check. I want to make sure that the index is correct for all of these. So what I'm going to do is I'm also going to print a board with that index set. So I'm just going to set bit with a 0 at the index of I, just to make sure, and we'll put it a capital P, just to make sure that we are going from the correct direction, or going from the correct space. This shows us correctly, so this capital P is where we are currently, which is what I wanted to check. So we are here, we move to here, and our captures are here. And that is absolutely correct. Okay, fantastic. Here, move to here. Let's make sure the double moves are all correct, which is going to be all the way up here. Okay, so this is, these aren't in use, right? This is just for logging, these aren't real. Okay, but once we get here, we have 2 possible moves and 1 possible capture. And then over here, we have 2 possible moves and then 2 possible captures. Fantastic. Looks like my math was just absolutely fine. And so we can just get rid of this here. Okay. So now we need to check and do the same thing for the white moves. It's going to be the exact same logic, just reversed. And that's what we're going to do here. Okay, so here. So for the first row, since we're doing this super efficiently, this is going to be if we are 55 or if we are 47. Then we will do the opposite, which I think is sorry if you hear talking in the background. My dad is talking to this new internet provider in our area. Is it legal for me? I'm pretty sure it is just legal for me to talk about Xfinity, Comcast just being an awful company. But they are an awful company. I mean, most, I think, internet providers just are awful companies. Most power companies too. But I think Xfinity, Comcast is just a specifically awful company. At least in my experience. So, also, as an aside, recently so the internet was off. We were getting I was getting really weird latency spikes. Just that's why I didn't stream for a little while, was because it was just really weird packet loss latency spikes. And what we found when we did some digging with the cables, I was like, we should check the cables if they're correct, because we checked the firmware and all that, and it turns out that there was water damage inside of our coax cable that comes from outside that goes to the box or whatever. And so that's still a persisting problem, but it was dripping out of the connector, and so we changed the connector, and now it's better. But thankfully, it's not a fire hazard or anything. But I'm unsure how bad the damage is actually. With the water being inside of the cable. Anyway. Let's change this from black to white. And we are still going diagonally, but we need to do some checking here that we're going to the correct side. So if we're starting at 55, then I want to make absolutely sure that, so that's starting from the right side. Oh, by the way. Oh yeah, this should all be minus. This should all be minus, that's correct. We're subtracting 9, which is incorrect. This subtracts 7, this subtracts 9, and then this subtracts both. Okay, and now let's do the same thing here for the rest of the ranks. Now, of course, you could just do this in a separate loop, but it would be slightly less efficient, and you know, I just have problems. I have like problems with things being efficient, right? I really hate when things are just a little bit inefficient. There we go. Okay, so if it's 0, we want to be going to, yeah, this is the opposite. It's this, and then it's this. And I'm just kicking myself because now I'm realizing that I have to write that for loop again to check this, that I deleted it beforehand. So this goes to board max and I++. And we are going to just print boards for both of these here. So let's print board the game white pawn moves with W, P. White pawn moves I. And print the board for white pawn captures, and I want to print out where we start as well, just like we did beforehand. So I'm going to print out the set bit for 0 at the index of I. And we will make that a lowercase case p, just so that we know that that's that board. So yeah, let's go check that out. Okay, so also what we want to do is do the index thing. So let's go printf index I. So this is going from index I. Sorry, I just got distracted by a notification on my other monitor. My bad. Okay, so this is going to give us the index so that we know where we are in the loop. Okay, so as you can see, we reached the end of the loop and we're on the last space, but these are not real boards. These boards have nothing in them because these aren't legal positions. Okay, so starting from here is the first correct position, and as you can see, hold on. This is where we are starting from. These are the legal moves forward, and our capture appears to be incorrect. We are going in the wrong direction. So I was incorrect. Actually, these are swapped. These are swapped indeed. These are backwards. Okay, so let me check this again. So our first legal position is starting from here. We go up 2 spaces, and then our legal capture is to the left. And same thing here. We start here, go up 2 spaces, legal captures to the side. Fantastic. Okay, this looks correct. We start here, go up 2 is incorrect. Go up 2 is incorrect. Okay. this goes up to, okay, so we're going to 1 extra. When it comes to the double moves, we have 1 extra. So this is going to be greater than 47. And then we will start at 47, I guess. Okay, a bit of lag again. The reason why maybe they're holy laggy mouse. Yeah, so the reason why there's probably some lag right now is because I usually stream at 720p because my computer is bad. But today I decided to try 1080 because I did all this fancy, you know, changing to my environment and all that. And so I was like, okay, maybe we can get away with it for once, but it looks like we're not. And I might have to just stay at 720p, which is sad because I think people really like it when I'm at 1080. Okay, so this is incorrect. This is wrapping around. Oh, because we didn't change this to 48. This is 48. Okay, so that should fix that. So let me check that out. Okay, and the lag stopped. So yeah, it gets like this encoding overloaded when I've been live for a long time, and that's the reason why. So 1 up 2, left capture, that's correct. Let's check the other side. This 2, yep. 1 up 2, capture the side. That's what we want to see. And then 1. Okay, so this is incorrect. No, this is correct. 1, 1, 1. Yep. Let me check the other side. 1 up 1. Capture the side. Went AFK, now I'm long. Lost but hurry progress. Yeah. We did hit a big hiccup for a while. It turns out that bitwise operations in C are 32-bit, which means that, which was why when I was like logging my king moves, it was happening 2 times, right? It was happening 4 rows down, right? And so what was happening was that when we printed out our king moves, we were checking the bit against a 32-bit number, even though we had it typed as 64-bit. And what that looks like, right, is when you bit shift over, 32 indices, it's going to register, twice for a 64-bit, right? Because it wraps around. And so what we had to end up doing was, I just had to like Google it, right? Is that we have to cast before we shift over. So we have to cast here, right? And we have to cast here. And we also have to cast here, which I didn't do. Which is really stupid, but it implies that this 1 is 32-bit, right? And so you have to put this as 64 before you shift it, which is very interesting. I would have not thought that that's the case. But yeah, we can go back to all of this. Why I extended this was because I was confused at why it was happening, and so I was like, let me just stupidly simplify the code until but yeah, I was really scratching my head. You do 1 UL prefix. I tried the ULL thing, I don't know. Does this really work without casting? I looked it up and apparently you have to cast. But maybe there is a prefix. I did try one ULL index and this actually didn't work without casting. Try it? Okay, I'll try it. I'll try it, but I did try it earlier and it didn't work. Maybe it does work because what I was doing is that I thought it was a problem with the board not being 64T, and so what I was doing was I would initialize. I said beforehand that board equals 0 ULL or 0x0 ULL, and that was what I was passing into this function because that's what I thought the problem was. But maybe this works actually. Let me test this. How do I test this? Let's well, this is kind of becoming an aside now, but let's comment this out and then let's print out our king boards again. So just at the end, let's just print board game king moves I with okay. Okay. Yeah, it seems to work actually. Wow. You're a wizard. You're a wizard, Harry. Okay. Well, that works then. That does work. Hopefully, is this fine to do? I mean, I wonder if this is like architecture. I should be worried about like architecture if you're talking about Windows versus maybe I should just keep it this if it's more explicit. But yeah, I think I'm just gonna keep it like this. But this is cool to know. Quick Google search says one ULL is 64-bit. Okay. Okay. Yeah, I saw on Stack Overflow that it said to cast it. But this probably works as well. It's probably the same thing. It's probably the exact same thing. Well, anyway, that's pretty cool. Good to know. Yeah, I was so confused because I was like, what is the problem? But it makes sense. It makes sense to me. But I mean, I don't really understand. Well, I guess it makes sense. I guess it makes sense. In my mind, if the index is greater than 32, but then yeah, I mean yeah, it makes sense. I guess. Yeah, it makes sense. I'm just dumb. Nah, it makes sense. I'm just dumb. Okay, so let me just make sure that this is working still. Okay, so this is fine. Okay. Things like that, I'm just... Unit 64 is better because it's guaranteed to be standard int. Okay. We'll keep it then. I do kind of like that it's more explicit, to be honest, but it is going to be kind of annoying to have this everywhere in the engine. But if I remember correctly, I did have to do this in my other Rust engine. I think I did have to do. What I did was I just wrote it out explicitly, like, you know, uint64t blah 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 blah. How does stand-in guarantee it? It's something that you can guarantee yourself in C code. I genuinely am confused about how that works. As far as my understanding is it's like architecture based. That some systems have different. I mean, can you recreate it in your own code? To be honest, I don't really understand how the whole like byte in terms of like 32-bit, 64-bit architecture, how it works under the hood. I've always been interested in it, but I never really got it. But apparently some systems just do the math differently under the hood. And so there's no way for you to guarantee that it is a certain thing, that it is a certain amount of bytes, I guess. Okay, so as you can see, it's marching across the board, and it gets to here, goes up, captures to the side, here, goes up, captures to this side. That's good. Here, goes up, captures to the side. I want to get to the final rank. Gets up, captures to the side. Gets up, captures to the side. Gets up, captures to the side. Okay, so no more wrapping around. Okay, go up, captures around, doesn't wrap. Goes up, captures around. Okay, this looks perfect. It's guaranteed by the compiler. But how do you get the transparent looking terminal? For me, it's not actually transparent. I don't have a compositor because my computer is bad, and when I try to use a compositor in stream, it just doesn't work, right? And so it's not actually transparent. My real background is this, but I'm cheating. What I literally did is I blurred it in GIMP. I blurred this background in GIMP myself. You can do this a number of ways, though. If you have a better computer, the usual way you do it is you take a compositor like PyCom, and they have a bunch of options to blur, right? Any background, and it blurs over your current window. So this would be the same image that is here. You can also do this though directly in Ghosty, which is my terminal emulator. It just wasn't working for me. The blur wasn't working for me. So I just blurred it myself. But you can apparently do it. I can open up my Ghosty configuration here, which is like half the default comments. But if you can see it here, I was playing around with this blur radius, which is supposed to be how it works, but it didn't work for me. It didn't work for me. The opacity works, everything else works, but the blur didn't for whatever reason. So there you go. Is it Sway or Hyperland? This is i3. I haven't really experimented with anything else. I just used i3 because it seemed pretty simple, you know. And I kind of hate like customizing things, and I'm very kind of set in my way about things. Like I'm not a guy who cares very much about ricing. I think it's really cool. Like every time I see it, I'm like amazed by it. But I don't know. I never like got like I never get like a dopamine rush out of doing it. So that's why I kind of stick with the same exact setup for a long period of time until I like one day I just like get bored of it, and then I switch it. Like I spent like 4 hours kind of making the changes, and I didn't enjoy it very much at all. I was like kind of just like, oh my god, and now I have to change this, and now I have to change this, and now I have to do that. Like I don't really enjoy it. But I do like how it looks now, you know? But yeah, I just like when I see the people with the cool like animations, and like it like is a circle that explodes into a terminal window and stuff like that. I think it's really cool, but I also think to me it's just novel, you know? Like my computer is bad enough, it wouldn't be able to handle the animations, but even if it did, I feel like it would be really cool for like 10 minutes, and then it would kind of just be like whatever. I don't know. But yeah. Maybe I'm just jealous deep down and it's all repressed, but I don't think so. I just maybe it's just not for me, you know. I also think I'm probably at this point older than most of the people that are into that. I don't know. Maybe I'm not, but I feel like I'm kind of like I've got that kind of like old person opinion about technology and stuff, is that I'm kind of like, you know, very very bare bones with things. Anyway, so we have init piece boards, which generates our pawn boards for black and white, moves and captures, our knight boards, and our king boards, and that's it. And we did all this fun stuff with setting up our file masks, which we check against so that we make sure that we don't wrap the board. And yeah, that's neat. So we got all that stuff done. Inside of utils, we have these file masks now. And I want to do the same thing for the rank masks while we're here, because I'm not really sure what else we're going to work on today. There's probably something else that I can think of. Anyway, if you weren't here before, we have this neat tool that somebody made at trth.dev, bitboard viewer, and what it does is you can see within our engine this is 64 bits, and we can toggle them here and literally just get an output that we can copy and paste in for all of the boilerplate, which is really helpful. It's something that I discovered way too late. But these masks are important because these masks are going to be used for evaluation for various things later. You will see. Writing is definitely a form of art. You gotta have the dedication to go really far, make everything pretty. Sometimes you just want things to work without worrying about the looks. Yeah, that's fair. Yeah, I think it is. There is definitely an art component to it. I have seen some really cool things. Specifically this one YouTuber. I have to add ULL to this. I know. There's this one YouTuber. I forget her name. Or their name. I'm not sure the pronouns, but they do like ricing tutorials. I'm sure you probably have heard. Got blue hair or whatever. Really cool. Dinky's caught. Nah, maybe that is it actually. That is it. That might be it. I don't really remember. But I saw this, the last one was one with like retro or whatever, and it looked really cool. Yes, that is it. Yeah, they also do make music, yeah. Super cool, super cool. So I do appreciate it. I think it's really cool, but also I don't know, I think I'm a boomer. Okay, I don't know what I'm doing here. All I have to do is this, go to the end. Yeah, I was just like being dumb there for a second. Oh, this is not going to work. There. Okay, so that is the rank masks for all the ranks. Except I think that this is backwards. Because I think rank A in chess is this one. So this is actually backwards. And oh, we're actually gonna do the thing. Hold on. How do I split on new lines again? Alt S. Oh my gosh, we're actually gonna do the thing. I'm so excited. And it's, oh my gosh, we did the thing. Oh wait, but it doesn't reverse it. It only does this. Oh. Dude, I was so excited to do the thing, but now I'm realizing that the thing isn't actually going to work. It was hype for a second because I used the fancy helix command to to shift the order, but yeah, this is faster. Okay. The rank depends on the color. Does it? I don't think it does. Well, I mean, the rank does, but the letters don't. You know, the letters definitely start from white and then they go up to black for sure. Like the letters, that's why when you have a board, the letters only go in one direction, right? Because this is A and then this is H and then black starts on G and H. But the rank in terms of, like when you say, you know, going to the 7th rank, that's, you know, that's, that obviously depends on where you're sitting, right? But in terms of us having masks for each letter, right? You're saying that white is on A and B and black. Yeah, exactly. So this would be A, B, C, yeah, no. And then this would be G and H. Okay. Okie dokie. So that's that setup. Don't know what we're gonna use that for, but we will use it eventually. Okay. Okay. Something else. We need to do a bunch of like boring stuff, which isn't like incredibly fun. But what I do want to do is we need to set up all of the pieces on Game-init, right? And so we want to make a function that initializes a new game. And I don't know about putting that in main. I like to keep things real neat. And so what I'm going to do is I'm going to create a new thing, and I'm going to call it game.c. Okay, and we will create a new, and it will be game.h. Okay. And we will make sure to link that inside of our build script. Okay. And we need to copy the boilerplate from earlier. Oh, by the way, I'm not actually, I went and got my coffee and then I didn't put my headphones back in. And so I've just been talking to my, without any music. So I hope the music hasn't been bad. Okay. Got my headphones back in. Okay, so this is going to be game H. Okie dokie. So right, so we will include, and what's gonna happen is we will have a function called int init new game, and this will take in a pointer to the game. Yeah, this is fine to take in a pointer to the game because for engine purposes, only one game is going to be existing. So we are going to take in an include to our types. Man, I'm so happy that I found this this music that I can play for free and not have to worry about copyright. It's so awesome, actually. Because I struggled with that for so long. Was getting my streams copyrighted and stuff. I probably would have hit monetization already like multiple times if it wasn't for all of this copyright issues that I've run into. But I'm so happy that that I eventually found it. It is in the description. And it's completely free for me to, like, I didn't have to pay anything. Anyway, so, they're not paying me to plug them, by the way. Okay. And just, this is just to be nice that we're making it an int, but I'm just going to say for now, we're just going to return 1, because we don't know if we're going to use that for anything. So we need to initialize a new game. Something interesting is, how do I determine what color we're playing as is a good question. For now, we don't really know. I forgot how we did that in terms of UCI later. I think I forget. For now, what I'm going to do is I'll take it in as an argument, a side color. and that will tell us what color we're playing. I'm going to open up in a split this with the type for our game, because I want to make sure that we are doing everything we need to. So we will reset the fen to start position, and let me grab that from here. It should have the start position. Yes, this is the beginning fen for a game. So I can just sprintf it into here, into game fen 0. We do want to clear this, of course, but I'll leave that to a reset function. For now, what I'll do is I'll just do this game fen 0. And can I just literally put this in here? Yeah, I think that's fine. Cool. Okay, so that's the start position fen. Now we need to initialize all of our piece data to start position. So we can make functions that do all of that separate, okay? Reset board. Okay, and that takes in a game pointer game, and we can make this, you know, for every, actually, instead of this, let's just do a set board, and then it's going to take in a game pointer game and yeah. Okay, so this is just going to take in a fen, and then we will read that fen to set the board to whatever fen. So let's say set board, let's call this set board to fen, and then we will just call set board to fen with what we just set, so game fen 0. Okay, so we of course are going to have to parse this, and this is where things get annoying, right? But it's not that annoying. It is annoying though. So we are just going to step through the characters. And we will parse the characters and figure out what it is. So we want to break when there's a space. So if fen indexed by I is a space, then we want to break. But otherwise, we will take it as a valid token. I'll tap for a bit and then came back and I was like, fem? No. Fen. Okay. So, we want to just parse it like this. we can just do this in a switch case. I think that that's what we did last time. Oh, but we can't do this because it's not all enum'd. Yeah, this is why Rust is better than C. This is why you should use Rust, is because you can do a switch case for this sort of stuff, but you can't do this. You cannot do you cannot do at least I don't think you can. You can? Why is this not giving me an error? I swear that I've had trouble with this before. Okay. Maybe I'm just stupid. You can do it on characters, actually. Maybe I had like some trouble maybe doing it with strings. Yeah, you can on strings. Yeah. Yeah, that's what it was. I think you can do pattern matching in Rust on strings, though. I think I was trying to do it on a string, and that's why. I think I was trying to do it on a string. Anyway, so that's what we are going to do. We will do what's a not copy and paste way of doing this? Let's do a function that is void set piece. That takes in a piece and a piece data, and a pointer to the data, and actually then we don't need the piece if we have the data. Actually, yeah, so let's we don't actually need this. We just have to have this, and then so let's just for now all we need to do is data board set piece at in index, and we'll take in the board. We want to set bit data board at the index. I'm dreading doing the whole. I have to make the all the stuff that translates from move notation to index stuff. But for now, I don't have to worry about that. Okay, so this is all set piece is going to do for now. So we do have to do something here, which is going to be, I'm going to go to game pieces. I'm really regretting. Actually, you know what? We're gonna go and change that right now. This should not be. This should not be like this. I don't know why I thought that this was okay to do this, but it obviously has to be this. You can't have lowercase enum single letter, like that's not happening. I don't know why I thought that that was okay. I just didn't really understand the ramifications of it. I think. We also want to make all of this uppercase. All of my enums always are uppercase. We want to do this before we have to refactor the entire code base, because I was just, you know, not really thinking. All of my enums always end up uppercase, just because I like my variables to be lowercase and my enums to be uppercase, because that's the better way of doing things. So this is going to be black rook, right? And the index will be, okay, so we have to do some math there. This needs to be an address. So we have to find the position in the fen. Okay, so we need an int int current space equals 0, and we need a step across. So okay, so we will by default increment by 1, but there are many places where we don't want to increment by 1. And that's going to be determined by if it is a digit, right? So if, is this a thing? Is digit? I feel like that's a thing. Takes in an int. Or maybe we have to strittle it. Hold on, I think that you can literally just check against a certain number, right? If a character is a digit. No, it is digit. It is digit. It's in ctype.h. Okay. Okay. Word. I definitely have used this before. So if is digit, right, we have to make sure that game.h includes types, and we, why is this giving me an error? Huh. Okay, well, it isn't giving me an error. Never mind. Okay. Also, we want to switch and then increment the space by 1 because it isn't a digit. We obviously want to have a case. Oh my gosh. Case for if it is a slash. Yeah. So if it's a slash, then we want to break and not increment it. Also, this I is going to be current space. This seems lame, but what I could do is I could literally just do current space minus equals 1. But I probably shouldn't do that. Or chess, you'd implement custom mechanics, yeah. You know, there are some people that are, you know, working on weird chess games, for sure. Okay. So we increment by 1. What we could do here is, the most clear way to do this is have an int skip spaces that will just be defaulted to 1. And in the case of a slash, we are not going to skip any spaces. Or actually, no, we don't skip. So our skip spaces is going to equal 0. And at the end, we're just going to, after this else. This is the most clear way to do it, is the skip spaces. And if we have a digit, then that is the amount of spaces that we want to skip. So I will go into that, and we need to do a, so skip spaces is going to equal the stritol of the fen I. Actually, I forget what this takes in. I have to look up this can't work on a single character, can it? Don't need a handle slash? I do need a handle slash actually, because it's still... Oh yeah, I could just like literally have just a default case. You're right. You're right. The reason I have this slash though is because of FEN notation. Is because of these slashes. I guess though you're right that we could just have a case default, or is the syntax just default? Is default skip spaces equals 0, and otherwise it's just gonna be 1. And then you have all your different pieces. But I need to figure out, I've only done this with strings. Let me look up how to do this. I want to see the ASCII way of doing this is, you subtract 0. Int equals the digit character minus the ASCII of 0. Okay, got it. Yeah, I've done that before, but I forgot how to do it. So this is going to be this minus the ASCII character of 0. And that will give us that will give us, so these are the amount of spaces to skip, right? So when it's 4, you skip 4. Yeah. So there we go. I think that just works fine. Okay, so we need to unfortunately do this for all of the different pieces we have, and it makes sense to just go in order. Unfortunately, the beginning of a chess engine is a lot of this, because there is a lot of, you have to parse information is a big part of it. I love that you can do this in Helix. It's like one of my favorite things. It's like a little kind of game you can play with the multiple cursor thing. It's kind of like you set up a combo to do. I have to remember to switch these to white every other one. Funny thing was working on my own project where I have to map integers to characters and forgot that I can just subtract ASCII for my characters. Yeah. I came across that problem once and then I Googled it, and then Stack Overflow just kind of gave me the answer for it a while ago. Okay. So I think that this is all of the things. Except for, okay, so if it is a space, then we break, which means that we have reached the end, right? Of the loop. And so if we reach the end and we break out of that loop, we need to do the rest. So we need the index of that. So let's have that. Let's have a current fen index that starts at 0, and let's just increment it every time. Current fen index plus equals 1, and then after this we want to start at the current fen index plus 1. And we're just going to keep looping. So from here, what we need to process next is the color to move, actually, which is always one character. So that's actually not a loop. That's just one character. So we will take this current fen index plus equals 1, we will increment it again, and we will just have a simple if statement. If hold on, let me think about this. So if fen current fen index, yeah, so you want to do current fen index plus equals 1 here, and then if the current fen index is equal to white Okay, I'm just going to set in case they are capitals, even though in Fed notation they should never be capitals. We just want to make sure. Else we will throw an error and we will return 0. And this should be an integer. I'm now realizing, yeah. So else we will printf incorrect fen. Yeah. Really what we should do is we should also reset the board to what it was previously here. I'm not going to worry about that right now. Okay, so what we want to do is the current side to move should be a variable on the game struct. And so what I'm going to do is I'll just put this here. Side to move. Okay. And our game side to move will be white. Oh, actually, is it white? This is always confusing. I think it is, so it is side to move. I was wondering if it was the side that just moved. There is something weird about that with en passant squares, I think, if I remember correctly. So we're going to increment the index again, because that's a blank space. And, or actually, we want, yeah. This is a blank space. So I'm just going to increment it twice. And I'll write the same comment here, that this is supposed to be a blank space. And then this is side to move. And then up here, we have the board state. Okay. And then next up is the castling rights. So that is... I wish they had an example of why don't they have... Let me get some perfed... there should be... There should be some test perfed results. There we go. Okay, this is kind of the page where we're gonna spend a lot of time later, because these are very good test game states that to test all your move generation on, and so that's what we will eventually be using. We won't touch it for now, but I'm just making sure that the how the castling rights look. So we will just iterate then. Okay. Actually, you can't actually do this. What am I doing? Okay. So we're going to go to the maximum for the castling rights. And we will just literally set it. So I'm not sure how I did it. Was I had bits. I had 4 bits that I literally just set. But I think it ended up being just less efficient than if I just had done it the other way. Yeah, I think now looking back at it, I probably just want to have it as booleans. I know that isn't very exciting, but because I remember it getting like really complicated when later down the line. Now you may be looking at this and like, why don't you just literally make an array? I don't know. I think that this is just actually a lot simpler, and simple is good. Like you could just have an enum and an array, but like I would rather keep it simple. So we will have switch case again. And we will have it with this. So that. Okay. Okay, so we want game white kingside castle. Sure. Okay, so we're just gonna do this. Okay. And then there's another blank space. And this is our castling rights. Okay, and then we will have a blank space and the current fen index will increase. Okay, and now after the castling rights, we have, is this en passant square? I feel like it is. Yes, en passant target square. So it has a file letter and then the rank. So it always should be two letters or two characters. And so we will store this as a index. Okay, so the en passant square, we have to parse it. So if our current fen index is equal to this, then this, if else we want to just, well, we can detect if it's an incorrect fen right here. So if our current fen index is equal to this, well, oh, hold on. Okay, we're not going to loop because that's, you know. Okay, so we're just going to say parse file, parse row, okay, and we will do them separately. So our fen Sorry, I'm not speaking. I'm just kind of going through the motions here. Okay, so I wanted to kind of make it in a way where I could detect if it's a character that isn't accepted, but it would be a bit annoying to write it. I would have to like do two switch cases in front of each other, and I just don't want to do it. So that's what you should actually do, is two different switch cases in front of each other. Okay, that's what we're gonna do. Yeah, this is so lame that you have to do this, but yeah, you do have to do this. So you are parsing the file first, right? File letter and then the en passant rank. Right. The file letter is actually... Wait. Oh, yeah, the file letter. That is going up and down the board. Okay. Wait, no, it isn't. Oh, files are columns, right? I almost forgot that. So we have to translate that to numbers, right? I think that that's it, right? You know what I think? Did you forget to turn off your compositor? So I got a Raspberry Pi Zero Wi-Fi. It's actually not composited. This is I blurred it myself. You got a Raspberry Pi Zero Wi-Fi with 1 gigahertz. That's sick. Yeah, you can definitely do some embedded stuff on that for sure. Somehow worse than my Surface. Somehow. Did I mix up ranks and files? Hold on. This to E4. I did. It's numbers going up. And it's letters going across. How did I not remember that? Okay, well, I need to go back and change some things. Okay, so the files are the letters. It's been a while since I played chess, as you can tell by that. And its ranks are numbers, which makes complete sense thinking back on it. Let me... So these are, so this is going to be file H, file A. It's going to stay exactly the same. It's just our names were wrong. So it's just converting digits to letters. I think that that's actually everything that we need to change. We also need to change though. Actually, are the file masks? The file masks are correct because those are files. Okay, so that stays the same. It's fine. Okay, so that's just that. Okay, fantastic. We should make a helper function that does this, actually. We should put this in a separate function, actually. So, let's return a file, parse file from a and let's just put a switch case in there for parsing that. We should actually do that for everything, but for now, let's just do this for this. So we're just going to switch on file. And do you actually have to do this way? You can't actually do that? It doesn't let you? Also, how's the engine going? The chess engine, it's going well. Game engine, I think I'm just taking a bit of a break from it. I was kind of burned out. Oh, that's why it's giving me an error. I'm just being dumb. It's because I didn't put a parentheses here. Duplicate case value. Okay, yeah, so this is completely fine. I was just being dumb. You don't actually need a break here. Maybe it's good to put it. I don't really know. I think that it just returns. Anyway, it's good to make helper functions for all of this because otherwise you run into errors later. Oh, this song sucks. Oh, sorry, I probably shouldn't. I probably shouldn't be, say that. Okay, so we want to do this for capitals too, just in case. Even though chess notation should never really have capitals for files. I'm gonna probably take a break for dinner soon, but I will probably be back for a while after that. Because I am enjoying this. Okay, and then, oh my gosh, the lag came back. Yeah, I mean, this is really annoying. We are going to printf here. Okay, and then we will return 0. Okay. Okay, so that's that. So then let's just put that down here. Instead of any of this, we will just EP file equals parse file with the fen current fen index. Actually, you know what? Okay, let's do that. Let's do that. Let us make this return an integer. And if it is, let's just return -1. And we'll just have a stopover where we check if it's -1. And if it's -1, then it's an incorrect thing. So let's just say if our EP file is -1, then we want to printf incorrect file in fen. Returning. Okay. And then we can set it to, well, let's not set it yet, because we want to set the index to the square. Anyway, we want to now parse the row, also known as the rank. Okay, so we need to do the same thing with the ranks. Same exact thing. Going to, you know, it's gonna be one of these things where we do it once and then we don't have to do it again. Actually, this is going to look a bit different, because we can go if not is digit with our rank, then we can just return -1 here. And otherwise, we just want to return the the thing is, if it's it starts at 1 and not 0, so to get that, what you're gonna do is you're gonna return this character minus the ASCII value of 0, but you also want to add 1 since it starts at 1. Oh, but this is giving me we want to get the enum. Well, in that case, we can just do this, and then it will give me the enum. Okay, so EP rank equals parse rank. We also want to go do that, and then we want to parse the rank for the fen, current fen index, and then we'll get the EP rank out of it. Okay, and then we want to check if EP rank is -1, then we want to throw the error. And we want to return 0, and then we want to increase the current fen index, of course, and then now we can actually get the index, and that's what we want to do. Is now we have the enum for both of these, so we want to have a file I wish you could, you know, name these the same thing. You could just cast it. I want to make a function that takes in a file on rank and gives us an index. We will say, let's just keep it real simple. File and rank to index, because we might end up with a function that takes in it in string form as well. So I just want to have a file and rank, and our enums are set up in a way where 0 is 0 and whatever. So I believe though that that ranks start at the white side at 1 and ours are the opposite way. So we're probably gonna have to do some weird math here. Okay. So the ranks are gonna be weird. The ranks are gonna have to be weird. So let's have an int output equals 0, and let's start by saying if the rank is 0, which is 1, this could be the opposite. So we want to flip it. 0. If it's 0, we want it to be 8, but we want it to be 7, and if it's 7, we want it to be 0. So we could just do I wish that you could do this. I usually just use fabs, but is there a way to... It's an stdlib. Do I have to... Okay, it's mad at me because I didn't cast it. Okay, so now if it's if it is 7, then it becomes 0, and if it was 0, then it becomes 7. So we flip it. Reason that is important is because we want this flipped file to be multiplied times 8. So that's what the equation is going to be. Is going to be the flipped file times 8, which is basically the amount of spaces in a row. And now we need to add the... Oh, actually, this is rank. This is rank. Our engine's convention starts black at 0, so we need to flip it since ranks start at 1 for white. Okay, so this is that plus the file. And I think the file, you could just add file to it. Because file goes from 0 to 7, which is going across. And we don't need output as a separate variable. We can just literally return this. Cool. So that is what will give us the en passant square. Finally, I want to call this en passant index. And our game en passant index will equal that file and ranked index using the EP file and the EP rank. Okay. And finally, there we go. Okie dokie. Now I just need to make sure it takes in a file, takes in a rank. I just want to make sure that I did that correctly. Where's the function? File and rank to index. Takes in a file and then the rank. Yeah. And the rank is the number. Okay. Okay. So now we increase the fen index and then it's a blank space, so we increase it again. Okay, and then last two things are half move and then full move. Which we can just literally, I think I just kind of want to put them as this. But I think that they can be multiple digits, and so we have to process them as so. And so how this becomes kind of interesting, where I think we want to actually make a buffer here that we stritol it is how I'm going to go about it. And all we're going to do is we will for loop and we will if the current fen index is a space, then we want to break, but otherwise we want to count, and we are going to concatenate all of this into one string, I think. Actually, yeah, let's just call stricat with half move string and the actually we can just do this like this is okay, and we want half move string to equal the fen, current fen index, indexed by the half move index. Okay, and then at the end, we want to add an escape character and then stritol it. So that's what I'm going to do. Half move string. You could of course break it and go past the max here, so we need to also check for that, but for now let me just do okay. So how do we check for this? Yeah, that seems about right. And we are going to stritole it with, how do we do this again? It's a pointer to the beginning, end pointer. I don't think you can just pass null for that, and then it's base. I don't really know what the whole base thing is. I think I just set it to 10 and then I forget it, you know? Null 10 is what we're gonna go with, and we're gonna follow the exact same pattern for okay, another blank space, and we will follow the exact same pattern for the full move. Oh, whoops. Okay. Okay, this seems good. Hopefully I did all of this correctly, but, yeah. No clue if I did. Also, I should just make a function that, that just parses... Oh my gosh, he's going fast. That takes in a character piece, and this is just going to literally take in all of this and just literally do that inside of here. Just to be super neat. So instead of this set piece, we are just going to return that. And we will do that for all of this. Much more clean. Yeah, I should just probably copy and paste this all the way down and just redo it. Actually, did I just get rid of all that code? I think I did, right? Yeah, I can't do that then. I have to go back and, well, I could just literally copy and paste this down there and then save it. So okay, well, we already messed up the undo history, so unfortunately, we have to redo that. Are you gonna have an AI for this game so you can play against it? Well, the goal is in a chess engine is that it is an AI. Well, it's not really artificial intelligence necessarily. It's computational intelligence for sure, but yeah, that's the point, is to have a chess engine that that basically, you know, you put it in a position and it gives you the best move. And of course you can play a game against it. I made a chess engine in Rust before, and it definitely could beat me, but it struggled. It struggled on the chess against other bots in terms of rating. You know, it never got to grandmaster status, you know. So that's the goal for this one, is to make a proper grandmaster engine. That is the goal. Okay, so that is that function that parses the piece. So now we can have a much cleaner little thing here. Okay, so that's the piece, and now we get an integer back, and so if piece is -1, else we just set the piece. But if it's -1, then we have to check what it is, right? And so we can do the switch over here. We want to look at the character, and if it is a dash, or I kind of want to do this just in case. But it's going to default to an error. And then we will printf board state fen error detected, returning. And in this case, we will return -1. Okay, so if it's a slash, then of course we just want to continue. And I think I can just do a continue from here. Hopefully that's fine. I think I ran into an issue with that before. Otherwise, we want to set the piece that it was, and we can just index it by piece because it is enummed. Okay. Cool. Parse piece doesn't actually return an enum, it returns an integer that is the enum, but if it's not, then it's -1, right? Okay. So in the case of this, actually, you don't want to continue because you still need to do this stuff. Increment the fen index, actually. Okay. Okay. So okay, so that's that. So we have this init new game function that we can try. And it's going to take an hour game, and for now we will set it to white. Since the default fen is always going to be white. Now I have no clue how to test this. What we also want to do is we want to do the opposite of this and construct an FEN on the outside, like, you know, basically fen from our current board state, and that's a way that we could check this. That's kind of annoying to do though. I kind of want to just like, we already made that function in utils that prints the game board. And I think that that's what I kind of want to just check with this. I just want to print the game board for our current game and see what happens. Okay, so we have unknown type name bool. Interesting. I don't have std bool in here. Oops. Okay, hopefully that that gets rid of that error. Cool. All right, I'm going to give this a shot. Okay. Board state fen error detected, returning. Okay. So we are getting an error back. Okay, so let's do some tests. Let us printf just the fen. Let's try this. Okay, so the fen is correct. But we are getting a board state fen error detected. So it's here. So if piece is -1, then we get into here. Let's print the character, print the error character. At character, the fen current fen index. So let's see what character we're failing at. R, so the very first character. So we're getting a -1 from parse piece. Oh, that makes complete sense because we forgot the rooks. Okay, so we're not going crazy. We just forgot the rooks. I was so confused for a second. Thank God I noticed that, or else we would have been here for a while. Okay. So let's take a look here. Okay, so obviously our thingamajiggy that prints our board is incorrect. It's either that's incorrect or our parsing that's incorrect. But I'm taking a look here. This seems to be all correct. This is the correct order. It just has an extra space here. And I'm assuming that that extra space just is every single row it has an extra space. So I'm assuming these slashes aren't getting accumulated. And I know why that is. I know what that is. It's because this we have to change the skip spaces to 0. Because these slashes just mean that the rank changes. There we go. So now we have our board set up correctly. That's what a chessboard looks like. Except we did mess this up. These are not the correct. The letters are supposed to be at the bottom, and because I'm stupid. But let's fix that right now. We want to print the these are the rank names. They're just, this is supposed to be file names, and this is supposed to be rank names. Okay. Except that we're starting from 7 and going down. Okay, so we need to do some math to convert this. So this should swap it. Yeah. So yeah, let's just test that. Yeah, that's correct. That is correctamundo. Now obviously our spacing is incorrect. Everything seems to be shifted over one space other than the last one. And so we want to fix that. I think it's because of these. Yeah. It's because we have a space before the new line at the end. Oh, I changed theme. I did. Well, I mean, the theme is pretty similar. I changed the like the color palette a little bit. You know, this is kind of changed. This is kind of changed. The font is the big thing in the background. This is actually not a compositor because my computer can't run a compositor. It's just I did it manually. Just because I wanted to change things up a bit, I guess. Okay. I wonder if all you want to do is this. That's actually completely what it is. There we go. It's correct now. All we need to do is we need to shift this over one. Which is that. Okay, we need to shift it over two. There you go. That's our board. There it is. So that's what our board is going to end up looking like. and we set all the pieces in the correct positions. Which is really cool and fun. From our fen. So cool. Very, very, very cool. So the next thing that is on the list of things to do is to now generate the fen backwards from all of our data, from our booleans, from our en passant index, from our half move. What we want to do is we want to generate a fen back and get this string back from our internal board state, and then we will test that with a bunch of fens, and then that's kind of the setup before we do all of our move generation. As far as move generation goes, we have the basics down, right? This initialization stuff generates all the valid pawn, king, and knight bit boards. All we're gonna have to do is we will take in an enum for the piece and the color, and we'll take in that enum and then check the current board state, occupancy stuff, to find all of the valid moves and mask it, right? And that's very simple for knights and kings and what have you, but for bishops and rooks, I am going to look through my my old code base and figure out the magic numbers thing. It should be somewhere here. They should probably have it. There was never a really good thing on the chess programming wiki about it, but maybe it's sliding piece attacks. Yes, it's this magic bitboards thing. I wish that they so this is the page for it. I did have to find somebody else's magic numbers. Yeah, so I remember this, is that you have one with 512 and one that's bigger for the rooks. And then you take in an occupancy map of everything on the board. And a square. I don't remember exactly. It's the occupancy and the lookup for the mask. Is this really a multiplication? I think I did something very similar to this. Yeah, I remember on the forum there was some that I ended up using. But yeah, this stuff was super confusing when I first discovered all the magic numbers for rooks and bishops, because obviously there's a lot of math involved in all of this. But as far as like making my own generator, I don't think that I'm going to actually do that. So I probably have to like look up those magics again that I had. I wish that I could remember where I got them from. But I can't really remember. Anyway, I'm going down a rabbit hole here, but it is something that I am going to have to implement pretty soon if I want to actually do, you know, generate moves. So, I think that it was there's somebody specifically who there's some yes, Analog Horse has a write-up on it, and it's their numbers that I ended up copying, I believe. I have to right, I went to their this. I feel like they had a list of magics somewhere. Oh, there it is. Here it is. Found it. It is here. Here it is. These are the the magic numbers. I pretty much just copied exactly this. And it worked fine for everything. I didn't really fully understand how it worked. I did read this great article on it, and it kind of taught me how to do this, which you're basically just indexing a table, that you set up on a knit with rook and bishop moves. God, looking back at it at Rust syntax is so weird. Now, it used to be so normal for me, but this is just so weird. This is so weird to me. The whole as thing to cast is so weird. Keep it up, thanks. Thank you. So yeah, I have to remember how to do this. But this is how you do bishop, rook, and queen. All of this stuff for finding magic numbers I never really understood. I'm trying to read the code and figure out how to... You set up the magics, which is what these are. God, the whole... This is so weird. Like, what is this? And that's just so weird. The Rust syntax is so weird. And the arrows? Like, what is this, JavaScript? So weird. So I don't remember how the indexing syntax works in terms of Rust. But I think that this is a this is the type, and then this is the count. So it's an array of magic entry with the count of the amount of squares. That's what that means. So it's just 64 magic entries. So it's a lot less complicated than it looks, I think. And then this is an array of bitboards for the amount of squares. Yeah, this is the exact math that I copied. So the blockers, if I remember correctly, is the occupancy, like the occupancy map of the board, and you're ANDing it with this magic entry. which is taking in this magic, which you are indexing the square. So it's just the magic at that square. So use that entry, and that gives you the entry mask. And the blockers you have to supply. And then there's this wrapping multiplication that I have to remember how to do that. I don't remember what this .0 is, but you do the wrapping multiplication with the magic. And then you shift that over to hash by the index bits, 64 minus the index bits. And then that gives you the index into this array of moves. But you generate the moves on a knit. And I have to look through the code. The code has this, has how you generate the table here. So you make a table like this. Okay, so mythical for new page pull, thanks. I am going to take a break here for a little bit. Putting engine dev on hold? Maybe on hold, maybe I just kind of wanted to do something else right now. I don't know if it's burnout. I just was finding it really hard to write the code for it, you know? So yeah, I was just finding it hard to keep going right now. But you know, I want to keep streaming. So because of tech debt? What does tech debt mean? I'm not sure what that means. But I don't know. It's just I got to a point with it where I like stopped really thinking that what I was making was good, I guess, you know? Like I kind of reached a plateau with it where I don't know. My engine has kind of lost my game engine has kind of lost what made it unique and what I worked so hard to make, you know? Its own level editor. It's, you know, you can edit every triangle and all of that. Now you can't edit every triangle because every triangle has to match GLTFs that come from Blender. It's not technical debt from making not the best decisions during development, no. No, it's what I loved about my engine in the first place is now gone because I implemented animations, scene nodes, all of this, you know, complicated systems that rely on file formats that that has deprecated half of the stuff that made my engine amazing, in my opinion. You know, the ability to edit every triangle, every point, you know, changing every texture, changing every property, you know? You can't anymore. You can't. You have to use Blender to do that now. And that just fucking bums me out, man. That fucking bums me out, you know? But you know, I wanted to have skeletal animations and all this, and so the architecture ended up changing, the pipeline changed, so anyway. Yeah, that just bums me out that I had to change what I, you know, the cool parts of my engine, in my opinion, the cool parts, you know. Now it's basically just like any other engine, you know. It just takes in files and just outputs a scene, you know. I mean, that's not really true. There's, you know, a lot of things like light mapping and stuff that are still unique, but you know, it just bums me out. That's all. So I think that bumming me out just made me kind of want to work on something else for a while, you know. And rebuilding my chess engine is something that I always wanted to do, you know. So anyway, so this stuff is exactly like I remember it. You do this math to set up the table of moves. That is what you hash into with the magic numbers later, and you do this on a knit. And you malloc this to rook table size, which is somewhere else in here. It's got to be somewhere in here. I feel like that's a const. Where is this? Oh, here it is. Yeah. It's this. Yeah, this is exactly what I copied. As you malloc that. You malloc a size of moves to this amount, and then this is the amount of complete amount of boards that you generate. Anyway, that's what I'm gonna work on next, but I am going to take a break for dinner right now, and I might be back later, or tomorrow. I haven't really decided if I'm gonna come back for a little bit yet. I have been live for like 6 hours, so but it's pretty cool. We generated all of our boards. We now take in a FEN string and output a board. We haven't tested other FENs, but this is, you know, it sets all of our pieces at this position, and then we print it out. I can, real quick, test other FENs really, really quick, just to prove that I kind of know what I'm doing. Let's go to perf results and get another one. This, let's do this, because this is a full string. these are the strings that I used previously when working on this. Okay, so let me go delete all of this and fill it with this new string. And let's give that a test. And let's see. It's possible that this gives me an error. Okay, there we go. And we can test that this is exactly the state. It looks correct. This is this. So we have to look and check. But as we can see, rook's in the corner. This pawn. Yep. Knight here. Bishop, bishop. Yep. Knight here. Then a knight and a white pawn. 2 white bishops. Pawn, pawn. Queen, knight. Pawn, pawn. Pawn, pawn, pawn. Rook here. Queen. Rook, king. There you go. So that's the board, and yeah, it sets it up correctly, as you can see. Anyway, that's the first, I guess, episode of my chess engine kind of series. So next we will do the move initialization for the bishop and rooks, and you know, queen is obviously just a rook and a bishop in one, and so this is just going to be a much more complicated version of these generate functions, and then we'll start the actual move generation routine that checks against all of the current bitboards for other captures and what have you. Yeah, so I will. You're gonna send me a Ko-fi? Thank you. You will be my very first one. I really appreciate that. Yeah, that helps me keep my Spotify subscription running. I do want to get a USB hub so that I can have a webcam. The way I typically do my videos is I film my phone to get my face, but I don't have enough ports to have a webcam. Anyway, going to either work on this more in like 30 minutes to an hour, or tomorrow or the day after or whatever. But I want to keep going live more because I have not been in the habit. Okay, see you guys. Thanks everyone for watching. Feel free to join the Discord if you aren't in there yet. And have a nice night, morning, whatever. Peace out.